Welcome to Altium Designer PCB Routing. In this module, we will learn about routing including setup, manual routing, and the new ActiveRoute feature in Altium Designer 17. Starting with our WC Topping Project's PC board, you will note a few differences from our last module. The placement and the board size have been reduced and tuned to meet a reduced board size target, and we've added a few tracks to the board as well. Just a further note about updates to the schematics and rules. On the power supply schematic sheet, there was a directive for a net class called Power Nets. This same directive was added to the Relay I/O schematic output nets, as shown here. This provides a net class to the PCB engineer for those higher current nets to be used with a width rule. The schematic designer did not specify the width, but left it up to the PCB designer to better determine the proper width based on the copper weight specified for fabrication. This is one example of communicating the designer's intent through creating a power net class, while still allowing for the PCB physical constraints to be determined by the board layout engineer. Looking at the PCB, we see the rule that uses the power nets class for driving widths. One addition to the rules was adding the board outline clearance rule. The other change was made to add the CAN net class. This replaced the new class that we created by hand in an earlier module while in the PCB. This was added to avoid the potential of deleting this net class when updating from the schematic and is a recommended best practice. While we are adding the net class directives, including a width rule makes sense. Here is the net class directive with the included rule. Now when, or if we update the PCB from the schematics, there is no danger of accidentally deleting the net class. In combination with the PCB rules, the PCB preferences help drive both trace widths and via sizes. Opening up the preferences and looking at the PCB editor folder, let's navigate to the default subsection. Here we can set the Altium Designer default preferences for a number of the PCB objects. I like to set the default width to 10 mm if it's not already. Double-clicking on the track entry opens up its properties, and here we can see that it's set to 10 mm already. Click OK and leave it as it is, but if needed you could edit the width value directly by clicking on it and entering the new default value. Now let's look at the default via size. I like using a 30 mm diameter with a 16 mm hole as my default. Basically it lines up nicely with the number of the fab houses I use that are economical prototyping shops. You can edit these to suit your company's specifications or needs. Likewise, the other primitive defaults could be edited, and I would encourage you to investigate them in order to become more familiar with the options and update them as needed. Closing the Preferences window and turning our attention to the PCB, here in the PCB view we should open up the rules and start setting up the needed PCB rules, as well as checking to ensure that the schematic rules were imported properly. Here we can see the imported rules from the schematics, the schematic clearance constraint, and the schematic width clearance rule. We will need to edit the rules for trace widths and routing vias to allow us to use the smaller vias and to give us some latitude for normal trace width routing. You can see that we have already edited the values for our new preferred width and max width. Clicking on the routing via rule, we will update it from the typical default rule values to allow for a wider range of via settings. Setting the min hole size to 12 mm and preferred to 16 mm, and the minimum diameter to 25 mm with 30 mm for the preferred, we now have the ability to change the vias as needed on the PCB. Closing the rules, we can now get to the fun part, routing. There are a number of routing options in Altium Designer 17. Let's look at the new Route pull-down menu. We can see ActiveRoute, Interactive Routing, Differential Pair Routing, and interactive multi-routing, to name a few. There are a number of other routing features as well, including a number of unrouting options, as you can see here. Let's start with the basic manual interactive routing option. Looking at the layer tabs at the bottom edge of the PCB view, we see a tab highlighted. This indicates the current active layer. One quick way to move from one active layer on the PCB to another is to click the plus or the minus key. As you do this, you will note that the highlighted layer tab changes. Let's click on the top layer tab to start our routing on the top side. Using either the Route pull-down menu, or as I prefer clicking on the Interactively Route Connections icon, As we move the mouse over the PCB, it changes to crosshairs, and the status on the bottom left of the Altium Designer tool window shows the current interactively routing connection status. Now in this mode, if we left-click on a pad, this is where we would start routing, and then move towards the endpoint indicated by the connection fly line. One feature that is useful in Altium Designer while in the midst of routing is the ability to zoom in and out by holding the Control key down and spinning the mouse wheel. Likewise, the Shift key on the mouse wheel scrolls left and right like this. These allow us to get a better perspective on the routing path options. Now we can place the wire segment endpoints by clicking at the desired locations using the left mouse button. When the route is completed, right-click once to finish this route. To exit routing mode, right-click again. What if during your routing you want to back up on some of the placed track vertices? Hitting the backspace key will remove the last placed endpoint. Continuing to hit the backspace will sequentially remove the remaining endpoints back to the starting point. This is helpful if you need to revisit the track routing after having placed some of the segments but have not yet finished the routing. While we have an interactive route in progress, tapping the spacebar will change the bend of the current track segment, like this. Hitting the Tab key brings up the Interactive Routing Properties window, where edits to the trace width can be made, or we can change the via that we use when we change layers. Setting the trace width to 15 and the via to a 16 mm hole with a 30 mm diameter, we click OK and we can continue routing. Notice now that the width has changed for the track. Now to automatically generate a via and to move to the next routing layer, in this case it would be the bottom, but if there was more signal layers, it would move to the next one in order. Click on the plus key. This moves us to the next signal layer to the right in the layer tabs. Again, for this PCB, that would be the bottom. As a result of the layer change, a via was automatically placed, and we have switched to the bottom layer for the track. Now you can see that it's in blue. Note that the layer tab on the bottom is now highlighted, again indicating that this is our active layer. With a many signal layer PCB, the same method of changing layers during routing is possible. The only difference is that the plus and minus key will drive the track to the next signal layer, with plus moving to the right in that stack and minus moving to the left. One thing that trips up new users arises from the concept of net naming for tracks. This occurs when starting a route mid-PCB without originating on a pin, track, or a via. The track being laid down does not have a net name associated with it, so the track property window would show a net name of no net. Not a big deal until you try to connect it to any other object that has a net name associated with it. This track cannot be connected to any other net, as it would be a short and either needs to have a net name added to all the segments using their property window, or deleted and started from a regular object that has a net name already assigned to it. While it is faster to start on an object in the PCB with a net name assigned, if you have a track already laid down that has the no net assignment, simply double-click on the track and use the net pull-down menu to select the right net. If you start to type the net name, typing G, this would cause the menu to jump down in the list of names, speeding up the selection process. Now we have assigned the ground net name to this track. One other method that works well with the series of traces needing to have their net names set is to use the ESP, or Edit Select Connected Copper shortcut. Select the entire track, and now open up the PCB Inspector panel if it's not already open, and edit the net name field to add it to the selected tracks. There are a number of routing styles available when laying down tracks. Starting a route and hitting the Tab key, we can explore some of the track styles. If we have the 4590 restriction set in that checkbox, as you can see, the track styles would be limited to those two topologies. Clearing that checkbox and returning to the routing, we are now able to toggle through the full list of track routing topology styles. We can do so by holding the Shift key down and tapping the spacebar. Notice the status line changing. This indicates what the current style will be used for the routing. And now we can see additional modes, such as 90-degree start with an arc and other arc options. In addition, the any angle route option is available. Although I do not recommend using it, it can come in handy in certain instances. Now that we have some nets routed, we can take advantage of the loop removal feature for cleaning up routes. Taking a quick peek at the PCB references, looking under Interactive Routing, we check to see that the Automatically Remove Loops checkbox is in fact checked. This is a most useful tool feature. Going back to the PCB, let's try this feature out. Click on the Interactive Routing and then left-click on a segment that we want to reroute. Now drawing a new track, we see that the effect of the Auto Loop Removal setting, the now redundant tracks are removed. This is very convenient, but I will disable it for adding some parallel tracks, like for example the power routes for the 12 volts supplies to the relay connectors, or in another instance a multi-layer PCB antenna. Once I have finished the parallel tracks, I switch back to enabling the loop mode removal. Note it does not retroactively remove loops, but if you modify a net with parallel tracks in it, it will perform the auto loop removal, so be aware. Note hitting the tab while routing, you can set or unset the automatic loop removal setting. This is a more convenient way to change loop removal when in the midst of routing rather than navigating to the right preferences window. Now with some of the tracks placed, often they need to be moved or adjusted. One way is to just reroute them. Another way is to select the segment and using the mouse left button, grab and adjust the track like so. During the process of routing a design, a typical situation arises due to multiple tracks already having been routed. These block adding an additional track. Altium Designer allows for routing in between existing tracks in the push and shove mode. Adding a new track will cause the existing ones to move and to make room. Note there are limitations to this, one in fact being the PCB rules are still enforced. If adding a track breaks a clearance rule, then the routing will not be enabled. Again, be aware that the rules will always be enforced. A new routing feature with Altium Designer 17 is the gloss selection option located under the routing pull-down menu. Let's select a group of nets. Again, I would use the Edit Select Connected Copper shortcut or ESP. And then I would click on the Gloss Selected option. The tool will gloss or clean up the selected nets. This can be quite handy for doing some generic cleanup. There are two more routing modes that we will address in this module. The first is Interactive Multiroute, and the last is ActiveRoute. Interactive Multiroute can be used for routing a group of signals like a data bus from one component to another. Selecting the pins to route first, and then clicking on the Interactive Multiroute icon, we can start the route of all the tracks in parallel, like so. Adding segment endpoints along the way by left mouse clicking can guide the placement of the group until the termination point is reached, or when you get near the termination point, hold the control key down and then left click and the tool will auto-complete the routing if possible. If you need to at that point, I would use the ESP shortcut again to select those nets and run the gloss to clean them up. The new Altium Designer 17 ActiveRoute is an effective and efficient way to route a group of signals automatically. Start with selecting a group of pins to route, and then click on the Route pull-down menu and select ActiveRoute. The selected pins will be routed on the current layer for them. In this module, we covered the routing and routing preferences for the PCB while demonstrating the various routing options available in Altium Designer 17.